Hi, everyone. Today I would like to introduce you the NVMe IP Core DDR reference design. I'm going to talk about the true about NVMe SSD performance, why DDR memory is required for data buffering and sustained data rate application, and I will show you our NVMe IP Core DDR reference design demo and performance result. To understand the true about NVMe SSD performance, for example, Samsung 980 Pro SSD, which is claimed sequential write performance, is up to 5,100 MB per second. You must read the entire asterisk carefully. For most NVMe SSD, the maximum performance is possible when cache is activated, which is intelligent TurboWrite cache technology for Samsung 980 Pro case. So what is the true performance without cache, or when cache is full? The easiest way to know true performance of the NVMe SSD is checking from well-known performance review websites such as Tom's Hardware. Here you can see the sequential write performance of various NVMe SSD. Especially Samsung 980 Pro, you can see how write speed drops significantly after intelligent TurboWrite cache is not activated or cache full. Also, during full disk writing, you can see that write speed sometime higher or lower than average speed. There is only two SSD model in this test, Intel Optane 905P and Samsung 970 Pro SSD. That shown stable and consistent sequential write speed for entire disk, which means that both SSD implement fast flash memory technology on entire disk, not just only cache region. Comparison between Samsung 980 Pro and Intel Optane 905P SSD. You can see that for full disk writing, Intel Optane 905P SSD can provide higher performance and more stable write speed. Anyway, there is no guarantee that write speed on Intel Optane SSD or any other's SSD will not drop during write operation. So if your application required sustained data rate writing to NVMe SSD, such as recording from constant data rate analog to digital converter or high-definition camera image sensors, what kind of system architecture is suitable to handle this kind of SSD characteristics? Let's talk about our NVMe IP Core DDR reference design, which is the solutions for sustained data rate application. Started with NVMe IP Core. A normal NVMe IP Core has a simple configuration that uses the FPGA internal memory. However, due to the characteristics of NVMe SSD, if the SSD cache becomes full beyond a certain amount of data transfer, or the SSD is busy in write cycle, the transfer performance will drop. The NVMe IP with DDR reference design use external DDR memory to absorb SSD's unstable characteristics during operation, allows to transfer data at a stable or sustained transfer rate. The very high-speed transferring logic uses an external DDR memory to be a big data buffer, instead of a small FIFO by internal FPGA memory. In our DDR reference design, user can check and adjust the DDR buffer size usage in the system. Therefore, user can know the requirement of the buffer size that matches with each speed. Here is the performance evaluation of the NVMe IP Core DDR reference design. The demo setup consists of the design gateway AB18 PCIe X16 adapter is connected to the Xilinx KCU105 FPGA board and connect the NVMe SSD. You can check the SSD connection with the Identify Device command. This demo uses a Intel 900P SSD. The Write SSD command inputs the start sector, data size, pattern, the write speed to the SSD, and select DDR size. Here, 280 GB data is written by the linear feedback shift register pattern. The transfer data size is displayed every second. When the write is completed, the transfer data size, execution time, write speed, and maximum DDR usage are displayed. At write speed 2285 MB per second, Intel 900P needs DDR size about 434 MB. Now we reduces speed to 1500 MB. The DDR usage is reduced to 371 kilobytes. We show the summary result on Intel 900P. When writing at 1000 MB per second, it uses 152 KB buffer. If increasing write speed to 1500 MB per second, the buffer will increase to 371 KB. And if we increase to 2285 MB per second, the buffer requirement is 434 MB. So, external DDR memory as big data buffer is required for very high sustained data rate application. One of the example application is 4K Ultra HD video recording at 120 frames per second. This application requires about 2800 MB per second at sustained data rate, which can be implemented based on our NVMe IP Core DDR reference design. So if you are interested in our IP, you can check it out in our website designateway.com, or just click the link in the description below.